Manufacturers are trying to automate dull tasks, find substitutes for the jobs that people don't want, and fill positions that are known for turnover. One of the most common material removal applications that our customers are trying to automate is weld grinding. A question we are commonly asked: should you automate welding or automate weld grinding first? In this video, I'll walk you through our answer to this question and how we approach the manual welds on these parts with our robotic belt sander and 3M's new Cubitron 2 cloth belt, the 984 FX Pro. Material removal is all about consistency. Consistent force, speed, feed rate, abrasives, and the part itself. For parts with robotic welds, they're extremely consistent and make dialing in the process much more straightforward. However, when it comes to manually processed welds, the variability between welders will be greater than that of a robotic system, often requiring additional process steps. We are able to grind and blend the manual welds in this video using the AFD 1240, the RBS 372 with a 70 durometer contact wheel, and a 3M abrasive belt. The AFD 1240 is an active force compliance tool capable of applying up to 215 pounds. While we didn't need this much force capacity, it gave us enough headroom to lift the RBS and apply an adequate amount of force in any orientation. For more information on how this works, we will link an explanation video for reference. With the consistent force of the AFD 1240, we are able to quickly level the peaks and valleys on the welded portion of these parts. This is thanks to the powers of unit pressure. To demonstrate this, I have a high heel, a work boot, and a piece of foam. When I apply a force with the high heel, I pierce through the foam with ease. When I apply the same amount of force with the boot, it just slightly compresses. The same thing is happening when we are grinding. When we reach the parent material, our unit pressure is spread out over a much larger area compared to the weld, much like the work boot. As a result, we can dwell on the parent material for a short amount of time without creating a low point in the part. So, if your part's welds have a small amount of variation, like the manual welds in this video, this can be overcome with the help of unit pressure. In instances where the weld height varies significantly from part to part, it's difficult to dial in the process even with the help of unit pressure. For example, the chosen parameters to finish the shorter welds could not be the same parameters for the larger welds, or there would be material left that wasn't blended. In order to account for this in an automated system, manual inspection will be required for each part. Then either you hand finish to finish blending the part, or you run an additional lighter pass with the robot. In either case, overcoming weld variation requires extra time, effort, and steps in your process, but not so for robotic welds, because the welds coming into the process are virtually identical each time. Going back to the question posed at the beginning of the video, should you automate weld grinding or welding first? As a company who has built their business around consistency and repeatability, having automated welds in the manufacturing process allows for the material removal to be streamlined and efficient. For manufacturers that can accept the extra steps and potentially more tedious process development, tackling material removal automation first can be done. More times than not, this decision will come down to which process is the biggest bottleneck and if automated would increase their throughput the most. We can't talk streamlining without mentioning the star of this video, the robotic belt sander. The PushCorp RBS 372 features a 72-inch long belt for arduous and continuous material removal projects. The three-point shape and design of the sander gives way to many applications with its choice of steel platen, contact wheel, or slack of belt. The part in our lab today utilized the serrated contact wheel for max material removal rate. Increasing pressure increases removal. All possible with the RBS 372, which boasts a high torque servo motor and timing belt drive, with a maximum belt speed of 6,719 surface feet per minute. Weld grinding, gate grinding, and surface conditioning are all applications in which the RBS 372 would be well suited. For our customers of regular manual welds, the 3M Cubitron 2 cloth belt 984 FX Pro 36 grit was an ideal solution. The abrasive material is a precision-shaped ceramic which is great for high-pressure grinding, descaling, and weld grinding. It's long-lasting to help reduce changeouts and downtime, making it ideal for automated and robotic applications. The RBS 372 combined with the coated abrasive belt was the quickest and most efficient solution for this process. Let's put this all together and check out the application video. One pass on each seam leveled the welds to the parent material. As we changed orientation, the active compliance device automatically adjusted the air pressure to maintain a constant force. We ran lengthwise along each seam, allowing unit pressure to keep assisting us in leveling to the parent material. Hey, welcome back. We create these videos to help explain material removal applications. If you have an application you think may be right for automation or want to see your parts in the demo lab, please send an email to sales@pushcorp.com. Check out our robotic weld shaving, grinding, and blending on carbon steel video for a different grinding application process. We'll link that in the description below. If you enjoy these videos, please make sure to like and subscribe. Thank you so much for watching. We'll see you next time.